Howdy, howdy, this is Mr. Potter. Welcome back to 7 Billion Humans. Last time we skipped a level and I didn't like that, so we're actually going to jump back here to level 31. This is our checkerboard organization. We have to put the numbers in a checkerboard pattern, but I'm hypothesizing this. I mean, I had this monstrosity, but let's try something a little bit different. Obviously, I need to get the memory location. Obviously, I need to take that memory location. And then if this is nothing, then I want to step some way. But I'm actually going to do something first. I'm actually going to just take a step to the left. That way, instead of the checkerboard being from where the printer is, the checkerboard's going to be just slightly different. And now, once I do that, I should be missing these holes entirely because I'll be on the white squares, which I should have been on, and not the dark squares. So we're going to, if this is equal to nothing, drop. Otherwise, I'm just going to take a step in any of these directions. So let's try that. So I'm going to pick it up, just take a step to the left. That also gets me out of the way as well, which is nice. So let's go ahead and zip that up a little bit faster. Notice now how we're deftly avoiding the holes. Cool. I just need to get those bottom two. Come on, y'all can do it. Excellent. Wonderful. Now it's not 7 commands. I used 8, so I imagine I can get that down quite a bit. And this average is so close to 100. I have a feeling that if I got rid of whichever command is my superfluous command, I could probably make it work. Like I could probably stick, well, I can't really stick this command anywhere else. I just want to, I know if I was to take that out and just automatically jump back to this, I'd get a bunch of griping from this because I'm trying to take from the printer that actually, I'm not sure that will work because they're always going to try in different spots. Yeah, there's a problem there. And everyone's just falling into holes. You know what though? I've already answered this question, so let's go ahead and put that, jump back in there. That jump which we had doing here. I think that was the one that worked, so let's make sure that works still. Wait, what, wait. Stop. Take from memory 1. Oh, I got those mixed up. This, after I drop it, I should jump back up here to take. Okay, let's try that again. There we go. Come on, you can do it. You can do it. You can do it. Come on. So close, so close. There we go. Thank you. All right. So let's go ahead and go back to the elevator. Let's work on data backup day, year 33. Just a moment, everyone. I'm just finishing up an important report I've been working on over a year. Type. Yes, and done. Excellent work, if I say so myself. Let me just save my work here, and file save as. No. Disk abort, fail. What? Stop, retry. Gah. Who would have thought my entire career would have come crumbling down due to catastrophic data loss? Haha. Don't worry, everyone. Did I fool you? Yes, I always knew I could have become an actor if this management job hadn't worked out. So I guess that's one of the other 7 billion jobs you could do. Data loss is something that can happen to anyone. It's nothing to be ashamed of. This is why I make backups. Let's all practice making backups over here. So each worker has a cube on both sides. The bigger number is corrupt. Overwrite this bigger number with the value of the smaller number and place them both back in the floor where they started. You've got a new command, set. Set works similar to nearest, but you use it to remember things on specific tiles. Numbers and many other things. Okay, so what I'm going to do is I'm going to get what's on the left, I'll call that mem1, and I'll get what's on the right and call that mem2. And then I'm going to do some type of comparison. So if mem1 is less than mem2, then that's what I want to do. I want to overwrite the bigger number with the smaller number. So if this is true, I want to overwrite mem2. So I actually want to pick up 2. I want to write mem1, and then I want to drop it. Else, I want to pick up mem1, write mem2, and drop it. So let's try that. So everyone's going to look at the numbers, find the bigger one, and rewrite it. Oh yes, nothing puts my mind at ease like redundant data storage. Cool. 8 or fewer commands? Aww. But I did it faster than the target of 3 seconds, so there's that. Now I imagine I could do something here. I could say that if mem1 is less than mem2, then I could do a swap. So if mem1 is less than mem2, let me try something here. If mem1 is less than mem2, then I can go ahead and say mem1 is my smaller one. Mem2 is the one I want to overwrite. So I can go ahead and say set mem2 equal to whoever's on the left, and set mem1 to whatever's on the right. And so now when I make it this way, mem1 is always the bigger of the two. If mem1 is less than mem2, no. So mem1 is smaller, so I want to make mem1 bigger. And so then what I want to do is I want to pick up mem1, write mem2, and drop. I think that'll work. Let's try it. So I can do that to get down to 8 steps. Basically, I'm just limiting the writing down to that. But it is going to be, oh, it actually ends up being exactly the right amount of time. I can totally deal with that. Excellent. All right, seek and destroy 1, year 34. Yes, I know what you're thinking. It's true. Every piece of data is a precious miracle. Workers, you have a line of precious miracles. Let's take a moment to appreciate them. They're also green and uniquely numbered. Each of you must find the littlest data in your line, Oz in that cube. But the problem with data is that small numbers take up just as much space as big numbers. And storage space isn't cheap, you know. You can see where we're going with this. So let's just take that littlest number and shred it. Excellent. So what I'm going to do is I'm going to go ahead and I want to step up. And then if my current cube is a data cube, then I want to set mem1 to whatever that cube happens to be. So that's going to be the first one of these. And then we're going to start our loopy part. So we're going to keep moving up. And so we're going to have if this is a data cube and this is less than mem1, then mem1 is going to be that. Actually, I think I can get away with this. And that way I can just do my loop here. And if up is not a wall, then I want to loop. So what's going to happen is I'm going to find the nearest data cube, which should be the one directly above me. That's going to be mem1. I'm going to slowly march upwards. If I'm at a data cube and it's less than 1, memory 1 is going to be that. If that's a wall, then if it's not a wall, then I want to keep marching up. But if I hit the wall, then what I want to do is I actually want to go down to memory 1. I want to pick it up. I want to go to my nearest shredder and give to it. So let's see what this does. So everyone's going to slowly march upwards. Hey, that worked. Awesome. 10 commands? Oh, seriously? And seriously, I'm just slightly over here and I'm just slightly over here. Oh my goodness. I gotta do something about this. Let's try that then. So it's definitely 9 commands, so I'm good there. I don't understand why it dips and... Oh well. Grrr! Intro to Calc for Art Majors. Year 35. What's 4 plus 2? What's 5 minus 3? What's 1 times 3? How is anyone supposed to know? We're not scientists. That's why you got a calculator. Yes, you can now use your new calc command. Use it to add or subtract or whatever else calculators do. Let's practice. Please add 1 to each of your data cubes below and place them black on the floor again. You can do this. So I want to pick up the cube that's below me. I'm going to take my item and add 1. No, add 1. I want to write mem1, and then I want to drop it. Will that do it? Excellent. So it's only 4 commands, and under 4 seconds. Awesome. Cool. Let's go to Dangerous Spreadsheeting, year 37. This does look hiccup. Did anyone tell you to have fun at the party? Oh, you weren't invited? Well, I'm sure cleaning up after a party is just as fun as being at the party. It appears someone got into the room and damaged a big bunch of data. So the tech support people want us to take inventory. See that table of data over there? Just add up each row and write the sum of each row, that column over in the right. Just add up each row and write the total sum of each row in that column over on the right. On the right. Ugh, it was a rough night. Watch out for the holes. Okay. So obviously I need to step to the right, and if use a cube, then I'm going to need to add to my running total. My running total is going to start at 0. So I'm going to say whatever's here plus my running total, that's going to be my new running total. And then if to the right is a wall, then I want to pick up and drop off after I write mem1 on it. So the only thing I need to do here is if to the right is a hole, then I want to do some fancy stepping. Let's just move diagonally up, and then if diagonally down is a hole, then we're going to go ahead and step right. So the thing is, what's going to happen is here, he's going to see the hole, step up here, and then step down again. So I'm going to go ahead and have him step back down. But this guy here, he's going to have to go up, over, and then down. And he only wants to count these, so I want to make sure he does all that fancy stepping, and he's going to land right on a data cube. So I think we're okay. Let's try that. So Gabe, 8 plus 0 is 8. You keeping track of that 8? Oh yeah, and we should probably keep doing this forever. Okay, Gabe, how's it going? Yeah, that's a 3. And 3 plus 6 is 9. And Gabe's 9 plus... Okay, and you moved around? Wait. You skipped the number. Gabe. Alright, so the problem is that when he reached here, he skipped this number and just started the walk around. So I need to make sure this if stuff is actually done first. So everyone's going to take a step to the right and then do their deft avoiding. Looks like everyone's doing some avoiding stuff going on here. Maybe. Wait a minute. Stop. People need to stop. They need to end. And I need to make sure that that is actually done first. So they're going to get here and not add 0 to the total. All right, so this is 2, and 3 is 5, and 15. That should end up being a 20 over here. That's not a 20, because he's not going back and hitting that number. So if it's a wall, we're going to end. If it's a data cube, then we want to do this. If it's a hole, then we actually want to jump back here-ish, to make sure we actually hit every cube. Okay, looks like everyone's hitting every cube so far. And 5 is 8, and 3 is 11, and 3 is 14. This guy's doing pretty good. This is 12, 16 plus 5 is 21. Yeah. Looks like we got some things happening over here. Numbers being written. 3, 2, 2 is 7. 10, 15, and 9 is 24. Yay! We are done. 13 commands or fewer? No. And just slightly over the speed limit on here, so we will call that a victory. All right, we have this little branch over here we need to take care of. Seek and destroy 2 and 3. Yes, you did notice, whenever we delete the smallest number, there's a new smallest number remaining. And if we delete that number, well, you see the problem here. Clearly, we need to shred all the data cubes, but not in any random order like we used to. Each of you must shred all data cubes in your column in the order from smallest first to biggest last. Cool. So I need to go back. I want to copy this, seek and destroy 1, because this worked. It got the smallest. And then we're going to go back to seek and destroy 2. We're going to listen to all the speeches. We're going to paste. And then once I give 2, then I want to jump back here. I'm worried that, this data cube is going to be here and someone's going to think this data cube is closer than this data cube. I just worry about that. Oh well, we will deal with that. Everyone just slowly makes their way up. And everyone's going to... Eek, that's not good. Mem1 is the nearest data cube. I don't understand why these people started going off in their other lanes. You know what, how about if I do this? How about instead of saying mem1 is this, we're going to say mem1 is... I don't want mem1 is the nearest. I'm actually going to say mem1 is 99. Okay, so Joanna has seen an 81. Now she's seen a 76. Now she's seen a 25. Now she's seen a 43. And Joanna's going to get her 25. Excellent. Now everyone's going back up to get cubes. Joanna's seen a 76. Joanna's seen a 43. Joanna sees a wall. Excellent. So let's go ahead and speed this up a little bit now. Oops. 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 That's not good. Let's make this less than or equal to. Because the only ones I had left at the end of that were the 99s, and basically because they weren't less than 99, they never got picked up. I think now those will get taken care of now. Cool. Excellent. So it's not 10 steps. Oh, it is 10 steps. Awesome. And I'm oh so above speed on that. Cool. All right, seek and destroy 3. You're 38. Sometimes when we get excited about an engineering problem, we can lose perspective and we forget about what's actually important. Yes, our last assignment was engineered very cleverly, but we still deleted all our data. Yes, let's not worry about who told us to do what. The important thing is that we need to show a little restraint. Please delete 1. Only 1 data cube. It must be the smallest one in the room. Let's all work together to do as little as possible. Cool. So what I can do is I can have everyone find their smallest data cube, come back down to the bottom. And then we had the problem where we had to sort. Remember the ones where we had the buzz saws on there? So we can actually get it so that this person has the smallest, and then she can hand it to her, and then she can shred it. So let's paste this. And instead of this, we're going to step down, and if down is not a wall, then keep marching, little ants. At this point, all of these people will have the smallest in their column. One of them will be the smallest overall. So now we need to sort these. And actually, I need to do something here. I need to say something like, if down is a shredder, then we're just going to have to wait for a second. So I don't want her to move right now. But what should happen now is everyone should slowly march up. Okay, down is not a wall. Oh, her. March. Yeah, I know it's not what you're expecting. It's what I'm expecting, though. So see how all of these are the smallest in their columns. So now we need to sort these. So now this is where we're going to have our sorting part of it. So if the person to the right of me is less than my item, then I want to step right. And if the person to the left of me is bigger than my item, then I want to step left. And this I want to repeat. So everyone's going to gather. And when everyone comes down here, they're going to sort themselves out. And then when everyone stops moving, that list is sorted. So what I can do, stop. What I can do is I can say, if this direction is a hole, or this direction is nothing. So the person, whoever ends up here, has got to be bigger than everything this way. So we're going to start going this way. If this person's gone, this person's going to see an empty space, and so he's going to know he's the biggest, and he's going to go that way. So I'm just going to have everyone who gets in that spot and actually that was supposed to be to the right, and the left is not equal to nothing, then, because I don't want her to leave when everyone else in the row has left. She is the possessor of the smallest number. So we're going to actually have everyone else jump in a hole. Let's see, everyone should come up, and end of the sorting happens, and then people jump in a hole except for Miss 12. Okay, so now what I need her to do is that she has to do some fancy stepping so that by the time she gets back here, there's only one person left. She takes the number away and shreds it. So what I think I'm going to have her doing is, instead of ending, I actually want her to step up, and then if up is a wall, then start stepping back down. And if down is a shredder, start stepping back up. And then if up is a wall, basically she's going to do 2 loops here. Step down. And then here, I'm going to put a jump there. Jump there. After they step, jump here. So she goes up. Wait, what are you doing? No, you don't get to, what'd you do with the knife? You ruined everything. You ruined it. So she needs to do stuff. She's going to step up. If down is a shredder, she wants to keep stepping up, and let's do that. That's true. She wants to step up, and then if Actually, let's do this. If down is a shredder, we're going to set mem4 to that shredder. And then if up is not a wall, then step up. Actually, I'm going to ask her to set her direction just to the right of that. And then if down is not a shredder, then step down. Basically, I want her to go up, down, and by the time she completes that, this person here should have the smallest number, and I'll actually be standing here. If down is, if up is not equal to a wall, then step up. And then if down is not equal to a shredder, then step down. We're going to put jumps in here to make sure everything gets done the way they should. So put another jump here. Put another jump here. Put another jump here. Then I want to step 2. Actually, I want to step 2 what we called mem4. I want to take from the person to our right, and I'm going to give to Senior Shredder. All right, so she's running laps. What? Why did these people... Oh. This all kind of needs to... No, stop. This all needs to be part of that if statement. In there. Because if she's Shredder Girl, then she's going to be doing all of this other stuff. Otherwise, everyone else is going to be just running laps as well. And that's not good. So we're going to step memory 4. We're going to take from, and we're going to give 2. So step up and jump, step up and jump. Jump. Get rid of that. Step up and jump. No. And step up and jump. All right, so let's try that. So she's going to run laps. Everyone's got their things. Wait, why are you getting 38? Stop. I need to keep track of you. Come on, beauty school dropout. So you're going to go up. Now we're doing down. Now we're doing up. Now we're doing down. I'm keeping track of you. Okay. Now we're stepping to memory 4. Take from the right. Give to the left. Wait, why are you here now? I want to step to memory 4 and then step diagonally down, then take from the right and give to the left. Okay, so we're going to step memory 4. We're going to go down like that. Maybe this will be it. What? Annie, you were the chosen one. Okay. I have a feeling this is going to work, but on accident. I can't step to nothing. Nope. What's going on here? Because this is not working the way I'm expecting it. All right, so the 9 here is going to be the smallest number. And that's good. Definitely not 22 commands. Well, this is awkward. Your solution failed more than 50% of the random tests. Interesting. You'll have to take a new approach. Here, I tried to reproduce conditions where your solution will fail. Try running your program against it now and pay close attention. All right. So 11 is my smallest number. So I'm looking at this. Okay, 11's my smallest number. Oh. Oh, and now you're doing that thing again. Actually, let's try not give to that. Let's try give to... mem4. Remember, mem4 is... let's make it the shredder. All right, so let's try that now. Okay, now again, my lowest number, there's a 15, there's a couple of 11s, here's an 11 right here. People are starting to run for the exits. And she did it. Cool, so I have a failure now. Interesting. All right, so we're going to go ahead and stop with this episode. Hope you've enjoyed the programming challenges so far. They've been pretty intricate, pretty involved. I know there are much more efficient ways of doing this, but it's fun. I'm enjoying it, and I hope you're enjoying it too. Once again, this is Mr. Potter. Thank you for watching. Have a great day.